afternoon, everyone, and thank you for joining us for today's stakeholder call to discuss the greenhouse gas models. This is kind of a follow-up to the July 26th, 27th EDAM workshop that we held in Salt Lake City. So today we'll be going through the greenhouse gas models a little bit more in detail. My name is Isabella Nicosia, representing ISO Stakeholder Affairs, and I'll be facilitating today's stakeholder call. And I'm also joined on the line by our presenter, George Angelides, our Executive Principal of Power Systems here at the ISO. So before I get started, I just wanted to go through a couple of housekeeping slides and reminders. So this call is being recorded. The recording is for informational and convenience purposes only. So any related transcription should not be reprinted without the ISO's permission. These calls are structured to stimulate an open dialogue and engage different perspectives with the understandings that stakeholders have reviewed the material. The spreadsheet that we're going through today is posted out on the EDAM initiative webpage. So feel free to open that up as we walk through it today as well. And then in the interest of time today, please refrain from repeating or reiterating what has already been said so that we can get through as many questions and comments as possible. And if you need technical assistance anytime during today's call, please send a chat to the event producer. Her name is Shreyas. We will be taking questions throughout the call today. So if you connected to audio through your computer or use the call me option on WebEx, then you'll want to select the raise hand icon, which is located just to the right above your chat window. But if you connected to audio outside of the WebEx, you'll need to press #2 to enter the question queue. And then just a reminder to please state your name and affiliation before making your comment or asking your question. And you can also send a question in the chat to either myself, again, my name is Isabella, or you can send it to all panelists. So before we hand it over to George, I'm actually going to hand it over to Anya Gilbert from Policy, and she's going to make some opening remarks. Anya?
Great. Thank you so much, Isabella. And good afternoon, everyone, and thank you for joining us for this bonus part 3 of the EDAM Greenhouse Gas Technical Workshops. We had some great participation last Wednesday in the greenhouse gas modeling discussion and spent some time on the examples that George developed in PowerPoint. And those PowerPoint examples are the background setup to the models he'll be reviewing with you all today, since we weren't able to get to them last week. I did want to note that the models George is presenting are simplified approaches to how each of the various greenhouse gas optimization approaches might work. And our goal here in this 3-hour session is that you walk away with an understanding of how these models work and the modeling differences between the different greenhouse gas approaches. So we're really hoping that this is an interactive session and that you walk away with an understanding of the models themselves. So please raise your hand, speak up with questions. I also encourage folks, if it's difficult to see the screen, to download the model. It is on the EDAM initiative webpage, and it was updated yesterday to reflect LEDWP's modeling approach. These are labeled in blue tabs for LEDWP's proposal, so please download that version. That might make it easier to follow along. I also want to note that the models themselves have color-coded cells. George will likely review this as well, but everything you see in black is a fixed input. Everything you see in blue is something that you can play around with and input yourself. Everything green is a formula, and in red, once solver is run, you'll see the results. So with that, please ask questions, and I'll turn things over to George for the modeling exercise. Thanks so much.
Thank you, Anya. This is George Angelides. Good afternoon, everyone. So we can pick up from where we left off last time. This was the model. Let me share my screen for just a moment. So this is what the example setup was during the work group last time. We had a system of 3 BAAs, and we had 2 greenhouse gas regulation areas, 1 and 2, that they were partially overlapping. 1 was overlapping with BAAA, and 2 was overlapping with BAAB. And we have BAA transfers, the blue arrows, and greenhouse gas transfers, the red arrow, into area 1 from area 0, which is the area that there is no greenhouse gas regulation, and the green transfer T2 from area 0 to area 2. What we're going to be doing today is we're going to walk through the spreadsheet that we have released, which I hope you can see on the screen right now, which has the model for these different greenhouse gas approaches. And we're going to explain how this model works. The emphasis is, of course, to show how the results are produced by the model. For the simple examples, we'll essentially verify that we have these results that we showed last time obtained through the model. And then we'll walk through some more complicated scenarios where we bring in transfer constraints and greenhouse gas reference, which in the simple example we showed last time, we had the reference to be 0. So here we'll also show some examples where the reference is non-zero. And on these examples, we'll be able to show you two different versions of what we call the hybrid approach. One being the one that we showed last time, where you have a full allocation without any constraints on the attribution, and then a settlement that goes similar to the zonal settlement. And then the Ldwp approach, which is very similar, but it considers constraints on attributions like reference and potentially other constraints. So we'll see all this. We'll start very simply with the resource-specific approach here. Some basics about the model, and you may be familiar with previous models in Excel that we have released. We follow the same conventions here, as Anya mentioned. Your blue cells are the input, and green are formulas, so you don't want to be playing around with those. And red is what the model calculates, your optimal solution, if you will. So as you can see, we have here all the generators and the loads, G1 through G8 and L1 through L5, as you saw in the presentation. You have the BAA and the greenhouse gas area where they belong to. For example, G1 is in area A, in BAA, area 1, etc. We have the lower economic limit. We put that 0 for all generators. You could put something different than 0 if you will, but it doesn't really have a material impact here on what we're trying to show. The upper economic limit is the capacity of the resource. We assume that all of it is bidding. And the energy bid is the column F. As you can see, as we had in the examples that we showed you in the last work group, we have the generators in the greenhouse gas areas to be more expensive because we want to have transfers, greenhouse gas transfers into these areas. Then you see in columns G and H, the greenhouse gas bid in megawatts and price for area 1, and the greenhouse gas bid for area 2 in IAJ columns. And of course, you only have this for the supply resources in area 0 outside the greenhouse gas regulation areas. We start with the simple examples where we have a greenhouse gas reference of 0. That's shown in column K. Then we have here in rows 16 through 21, these are your BAA to BAA transfers, both directions, A to B, B to A. In the simple example that we showed you, and what you see here in the stub, we have a limit of 999, indicating that we are not enforcing transfer constraints for this example. The small cost of 0.001 is a cost that we assign on transfers to have a robust solution so that we can avoid circulating megawatts. It's not material for the optimization, but it's material for having a robust solution. Let me move a little bit.
Let's pause here for just a moment, just to see if there's any questions on this setup. As George mentioned, we have the generators G1 through G8. We have our load represented. I think it might be helpful, George, to clarify column K. When you say GHG reference level, is that the same as the RSC or the GHG counterfactual?
Yeah, it is the GHG counterfactual. Essentially, we're limiting the attribution in the resource-specific approach to the amount of megawatts between the upper economic limit and the greenhouse gas reference. So I was going to walk through, this is really not in a good spot here. It persists anyway. So if I move a little bit to the right, you can see the control variables, what the optimization will solve for in red is the optimal energy schedule in column L, and then the greenhouse gas attributions for area 1 and area 2, and we only have values for the generators in area 0 for this. And then the next two columns is the constraints that we impose in the greenhouse gas attribution, one being the reference limit, what we spoke before, that the attribution is limited to the difference between the upper economic limit and the greenhouse gas reference. And for this particular example, it doesn't matter because we assume a reference of 0. And then on column P is the other constraint that limits the attribution to the schedule. So we never attribute anything more than the schedule, which is in column L. So these are the constraints on the attribution. I'd like to walk through all this first before we open to questions so that we have the whole picture here of what's going on. Let's see here. So if we go down a little bit, you can see that these red values in area 16 through 21 is the optimal calculation for the transfers, the BAA to BAA transfers. Then after that, with TA, TB, and TC, this is the net transfer for the BAAs. And the net transfer is the mismatch of the power balance constraint. We formulate for its BAA. And then in columns M and N, a little bit, what you see there, T1 and T2, these are the greenhouse gas transfers into area 1 and area 2. And there is a constraint here that we basically state that the greenhouse gas transfer into a specific area must match the sum of all greenhouse gas attributions to that area. So you can see we have in the solution for area 2, G4 being attributed to 130 and G8 being attributed to 200. So the total is 330. So the transfer T2 is also 330, and there is a constraint here in the model that essentially distributes the greenhouse gas transfer to the attributions, or the other way around, determines the greenhouse gas transfer as the sum of the attributions. This is an important constraint in the model, and it's the one that sets the marginal greenhouse gas price for its greenhouse gas area, because it's the shadow price of that constraint. If we move a little further down, maybe too much, we can see the constraints that we have in the problem. The objective function has three components. The 5300 you see here, it's the cost of the energy. So it's the energy schedules times the individual energy bits for the generators. The greenhouse gas attribution cost is the attributions times the greenhouse gas bid price, and all of these added together is our objective function. So we're minimizing both the cost of energy and the cost of greenhouse gas regulation. Where you see the zeros in rows 30 through 34 is essentially our power balance constraints for each BAA, 30 to 32, and then you have the greenhouse gas area power balance constraint, which determines what is the greenhouse gas transfer. So those constraints are formulated in the problem. And then when the solver solves, through the sensitivity analysis on the solution, which is provided by the Excel server as a separate tab that you can see here, it's called sensitivity report in the bottom. From that sensitivity report, we'll pull out the shadow prices. And you can see here that the shadow price for each power balance constraint at the BAA level is $70. There's no difference between the BAAs because we didn't enforce transfer constraints in this example. And then you can see the marginal greenhouse gas cost in columns M and N, which is $1 for area 1 and $4 for area 2. Then we take these shadow prices and we synthesize the LMPs. And essentially, the LMP in area 1 is the $70 marginal energy cost for BAAA, plus the $1 greenhouse gas, marginal greenhouse gas component, which brings the LMP to $71. The same for area 2. You have a $74 LMP, $70 is the marginal energy cost, and then you add $4 for the marginal greenhouse gas cost. So if you experiment with this, it's important to make sure that you have the correct selection for the sensitivity report in this box here, so that you pull out the correct set of prices. When you solve the problem and you select the production of the sensitivity report, it always puts it one tab before. So you can see here the sensitivity report is just before the result specific tab that we solved. If you need to reload the model for some reason, it's saved here. So let me pause here now to see if there are any questions, not on the solution, but on the structure, to understand exactly how the model works and what the inputs are, and how we calculate the optimal solution. And then we'll talk a little bit more specific about the example of the numbers that you see. Let's see if there are any questions on the model.
As a reminder,
if you're
Go ahead, Shreyas.
I'm sorry, go ahead. Sure. If you're connected to the computer audio or use the Call Me feature in WebEx, you may enter the question queue by using the WebEx raise hand icon located just above the chat panel. You'll hear a beep tone when your line is unmuted. At that time, please state your name and question. If you're just on the phone line and not using the WebEx audio, please dial #2 on your phone to enter the question queue. You'll hear a notification when your line is unmuted. At that time, please state your name and question. I do see one caller in the queue. Please go ahead, your line is unmuted.
Thanks, this is Colbert from Vistra. How's it going?
Hi, Kathleen.
Hey, I think I may just be being done. I'm going to ask you for a little bit of help, George. I'm looking for the load fork, whether it's the load forecast or the bid-in load, and whichever way we want to think about it in this scenario. Is it? I don't see a single value for each BAA, but am I missing it? Can you show me how you did that here?
So can you see this slide?
Yes.
So we had to split the load in each BAA to separate the load in the BAA with the load in the greenhouse gas area. So in BAA A, you have two loads, L1 and L3. L1 is within the greenhouse gas area 1. L3 is outside of the greenhouse gas area 1 because we need them separate. They have a different LMP as I showed in the example. The LMP in greenhouse gas area 1 has an additional component, which is the marginal greenhouse gas cost for area 1. So you have multiple loads. I'm going to go back to the spreadsheet. So you can see here L1 is 110 megawatts. We're assuming here that it's self-scheduled. We didn't add load bits. They wouldn't add much value in this example. So L1 is self-scheduled at 110, and L3, which is outside area 1, you can see it's BAA, area 0. It's scheduled at, it's self-scheduled at 290. Okay?
Thanks for going over that again. Appreciate it.
Yeah. So if BAA has 400 megawatts of load, but there is a split in BAA's A and B between what is inside the area, greenhouse gas area and what is outside. So the split for BAA, you have the A1 is 110 and A0 290. That's how it splits. And the other one splits the other way around. I did it on purpose. Splits 330/70. Is there another question on the model?
Sure. Do we have any questions in the queue?
I do not see any callers in the queue as of now.
Okay.
Okay. All right. So as you can see, the way we presented it last time, generator G5 does not participate, does not submit a greenhouse gas bid for either area. Generators 6 and 7 participate only for area 1. As you can see here, they don't participate for area 2, they don't submit a bid. And generator G8 participates, submits a bid for both areas. So we saw the solution last time, and this is exactly what we have here in the model. Roll a little bit to see the values. So all generators in BAAC, so 5, 6, 7, and 8, they're running at 200. Okay, they're running full because they're the cheapest generators in the system. And then the balance of the power is produced by G4, and G3 is marginal, running at 100 megawatts. That's what sets $70 the price over the grid. We don't have transfer constraints, so that's why you have one marginal energy cost over all BAAs. And the attributions are 110 megawatts that G6 has for area 1 to serve the L1, the load in area 1, which is 110 megawatts. And then we have a total of 330 megawatts of attribution to area 2 from generators G4 and G8 to serve the 330 megawatts of L2 in area 2. Okay.
Rich, could you speak to how that attribution was derived?
Oh, yes. So if I go back to the example that we showed last time, essentially, because generator G1 is expensive, the optimal solution will try to bring energy into area 1 to displace the expensive generator G1 to serve the load in the area, which is 110 megawatts. So you will see in the optimal solution that red 110 megawatt greenhouse gas transfer. The same happens in area 2. The greenhouse gas transfer is 330 megawatts to serve that load of L2 of 330 megawatts. And the optimization finds the optimal greenhouse gas attribution for those. The 110 megawatts for area 1 is generator G6, it's $1. And then You have generator G8 that provides the whole amount, 200 megawatts, to area 2 at $3. And then the balance of 130, because you have a 330 load, you need another 130 greenhouse gas transfer. It's going to come from generator G4, which bids at $4, and that's why the marginal prices for the greenhouse gas regulation cost, and I went too far down, are $1 for, here it is, $1 for area 1 and $4 for area 2. So these are the greenhouse gas marginal costs for the regulation. And once you have this shadow price,
Thank you for that. And maybe just a call out, Rafael, I appreciate that question. Please let us know if that didn't address your question in any way. Go ahead, George.
Yeah. So then here is where we calculate the marginal prices. So as I said earlier, $70 is your marginal energy cost. For area 1, you add that $1 marginal greenhouse gas cost, and you get $71. And there is $74 for area 2. So the settlement, we can look into that now. You have here is the energy settlement in column L, basically what you pay generators and what you charge the load based on these LMPs here, okay? And then you have a collection for greenhouse gas transfer, right? Which is the result of this energy settlement, okay? That's 1430. So you have a revenue, okay? You're not neutral on the energy settlement because there's price differential from area 0 to area 1 and area 2 because of these marginal greenhouse gas costs. So the market operator will collect $1,000 for 130 revenue, which is the revenue from the greenhouse gas transfer. And it's 110 for the transfer to area 1 and 1320 for the transfer to area 2. Why these values? You have a 110 transfer to area 1 at $1, which is the marginal cost, so it's $110. And then for area 2, you have 330 megawatts at $4. So you collect 1320. The market operator stays neutral by disbursing this greenhouse gas transfer revenue to the attributions to the resources. And if you remember, C5 got an attribution for 110 megawatts, so that's where this revenue is going to. And then the 1320 is distributed to G3 that had a 130 megawatt attribution, and to G8 that had a 200 megawatt attribution. So the market operator is neutral. This is the settlement that you have. There is a specific approach. Now I added some columns here just as a check to make sure that the resources are paid adequately. So no generator is paid below its bid. And this is the resource-specific solution for the example that we showed. Let's see if there are any questions before we move to the next approach.
Sure. Just a clarification question at the top. You'll see that there's energy bids as well as GHG bids for the different GHG regions, confirmation that the energy and GHG bids are co-optimized.
Yes. In this example, I assumed the same bid price for both areas. Whatever you see it's still $5 for both. But you can have different greenhouse gas bid prices. In the resource-specific approach, the bids are voluntarily submitted, all right? they're cut to something that represents the actual emission cost, but that also depends on the carbon cost for its area, which could be different. So there could be different bits for different areas. But here in this example, I use the same bit for simplicity.
Great, thanks for clarifying that. We did get a question on if you could describe all the balancing constraints used in the resource-specific model. So if you could walk through that, I think it would also be helpful, George, to re-examine kind of the constraints that you've set up, or the loose constraints you've set up for transfers.
Oh, okay. Well, you mentioned the power balance constraint too, right? This is the power balance constraint for area A. Okay, it's basically generation minus load minus the transfer. The transfer must be the two transfers, right? So as you can see, if I go up a little bit, so it's the generation in area in BAA minus the load in BAA and minus the transfer. So that should be 0. It's enforced to be 0. And it's 0 at the output, at the optimal output. This is enforced to be 0. So that's how we hold the power balance in area A. The same is for the other areas. And then you have a similar constraint for the greenhouse gas transfer, right? Which is basically requires that the greenhouse gas transfer being equal to the total of the attributions, which is this number. So that's how we enforce the constraints on the BAAs and on the greenhouse gas transfers. For the constraints on the transfers, on the transfer schedules, there aren't any here. Well, there is, but they're open. We have a very high limit. Let's see here. This is the outcome of the transfer. This is the schedule of the transfer. So you can see we have 400 megawatt transfer out of area C into areas A and B. 300 goes from C to A, and 100 goes from C to B, like what we showed in the solution here, right? 300 is from C to A, and 100 from B to C. These are optimally calculated. Okay.
And then there's a
so when we show,
go ahead.
Yeah,
there's a follow-up question on columns O and C, and then we'll move to the caller.
There was I think you asked how we enforce the constraints on the transfer. So essentially, what you have in the model further down, there's a constraint that says this schedule, this is the optimal schedule, and you limit it between 0 and 999. Okay. So there is a constraint in the model that says do not allow the schedule of the transfer to exceed this upper economic limit. I use the same column here for the upper limit on the schedule. The greenhouse gas transfers, they don't have limits, neither the net transfer. So TA is the net transfer for area A. So there are two individual transfers in area A, TAC and TAB. So this is the net. This is the minus 300 is the mismatch of the power balance constraint for area A. So that says that area A imports 300 megawatts. But there is no constraint on that. So we don't have constraints on the greenhouse gas transfers. The greenhouse gas transfers are implicitly constrained, but whatever constraint we have on the attributions, because the greenhouse gas transfer is equal to the sum of the greenhouse gas attributions. And if these are limited, and we know they're limited, I'll show you the constraints on those. These are the constraints. Basically, we have a constraint that limits them based on the greenhouse gas reference, it's 0 in this case, but here's a constraint, and there's another constraint that limits the attribution to the total schedule, so we can never attribute more than the schedule. So the greenhouse gas transfers are implicitly limited by whatever constraint you put on the attributions. Any other questions?
We have some on the phone. Isabella?
Yes,
Sure.
I do see a couple of callers in the queue. Moving on to the first caller, please go ahead. Your line is unmuted.
Hi, George. It's Mark Holman with PowerX. Can you hear me okay?
Yes, Mark.
Hi. First, thanks for setting up the Excel spreadsheets and the solver. It's really useful to work through some of these concepts. Just two comments at this point. One is just that the scenario that you've established here, a couple things just to note. One is that the energy price differences are $10 apart, but the GHG prices are not really what we would see in the real world at 0, 1, 2, 3, 4, 5. And I know it's just an illustrative example, but it's really helpful if we have time after you go through this example. If I can suggest a couple number changes that get us a little more realistic, I think we'll get more insights into what the algorithm actually does. Because there's a couple uniquenesses about these numbers, like the GHG numbers being very small and close together. The load in C is really small relative to its resources. It's only 400 megawatts and it has 800 megawatts of resources. And so it's dispatching those resources up because of the energy price. And that doesn't really show how the algorithm interacts with GHG and can dispatch an emitting resource up, but deem the counterfactual megawatts. So it'd be really helpful if we have a chance to go through perhaps a slightly modified run and just run the solver quickly, and I think we can show some of the outcomes that are concerning with the resource specific. On the zonal, which I know you're going to move to next, there's a couple issues I just wanted to flag for you as you walk through it. I think if you click on zonal and just look at your solver, you might have missed a cell. At least when I opened up the one from the website. So when you hit solver, I'll just show you to help you identify that. So when you hit your solver and you look at your equation, your objective function, I can't see it there. I think you might have missed G1. Do you see how your equation is starting at I3 and it should have started at I2? In your objective function?
I'm sorry. You mean, in the control variables?
Yes. Is there a reason you're not allowing generator 1 to change?
You're right. It seems I missed the cell, right?
Yeah, it's an easy thing to do. I know these Excel spreadsheets, it's pretty easy to miss a cell. I don't know that it changes the outcome in this scenario, but I think it's missing throughout, just as a heads up.
Well, it's good that I missed the most expensive generator that never runs. So, but
yeah, that's what I was saying. I don't think it changes.
But thanks.
Well, what it is, I think we're still struggling on explaining what we're expecting from zonal, because this zonal model does not have anything resource specific. And I think resource specific is a key element of the zonal approach. And so I'll let you move on, George, but it'd be really helpful if I can come back perhaps in a little bit and run through a slightly modified scenario, because I think it's really going to highlight that the resource specific will deem counterfactual megawatts that are clearly wrong. Thanks.
We'll do that, Mark, and that's why we're having this work group here. I specifically asked for 3 hours.
Again, thanks.
I was not sure we're going to use them all, but
so really appreciate it, George.
Yeah, and regarding the bid prices that you see, I put energy bids by $10, greenhouse gas bids by $1. The motivation was when I did the examples in the presentation. I haven't done the model yet. I haven't done the model, so I put numbers so that I can find the optimal solution myself by inspection. So separating the prices, helping in that respect. Then I built the model.
By you posting it ahead of time, we're all very busy, of course, but we got a little bit of time to just look at it. And I'm not sure I got it exactly right. By posting ahead of time, it was so helpful, because when we tweak the numbers a little bit, put the load in C up to something closer to its resources, and then put in typical coal and hydro emission rates and gas emission rates, we start to see what the problems are that we're seeing in the real world, which is it will dispatch up the coal, but deem the supply to come from hydro that is clearly not leaving the BA. And so that's the problem that we want to highlight, just how problematic at least we view this algorithm to be towards the cap and trade and cap invest programs. Thanks.
Right. So hopefully we'll have time, and I think we'll have time to play around with that. So once I walk through these examples here, we can have an open session where we can try things, and you can help me set up the problem. All right. Thank you, Mark. Any other questions or comments?
Yes, I do see one more caller in the queue. Please go ahead. Your line is unmuted.
Hi, George. It's Callie Weld with WPTF. Echoing Mark's comment there, appreciate you guys putting the solver together and posting it ahead of time so we have a chance to familiarize ourselves with it before this call. I was just curious on this, on the resource-specific example. I want to make sure before we move on to the other examples why the prices ended up the way they did. So if you go down to where you have the SMEC, it's 70 across all BAs, and that's because the next economic resource to be dispatched is G3 at 70. But then the reason it's the LMP is 71 in area. Oh, sorry, go ahead.
Yeah, the marginal resource is G3 because it's dispatched at 100 out of 300. So it's just the energy price at $70. There's no price differential between the BAs because no transfer constraint is binding. So that sets the marginal energy cost, if you will.
Okay, and then to that, I get you add the GHG, and so the $1 for the area 1 that ends up making an LMP of 71 is because even though the next megawatt to be generated will come from G3, the model will actually increase attribution to G6, even though G6 isn't dispatched up anymore. And that's how you get the $1 GHG adder.
Yeah, it finds out that the marginal cost of the greenhouse gas regulation is set by that generator. Who has the attribution for 110? Let me see. This guy.
Okay.
So this guy gets an attribution of 110. So if you increase the load here from L1, if you make it to 111, you'll probably see that this will be 111, which will cost you an extra $1 for the greenhouse gas, right?
Yeah, I ran that, and so that's. I just want to make sure that okay. Even though that the energy schedule didn't, obviously it can't increase above 200 because it's already at its Pmax. So I don't know. Oh, go ahead. Sorry.
No, you're correct in your deduction there. Although the energy schedule cannot increase, the attribution can increase. So that sets the marginal price of the greenhouse gas to $1.
Okay. So with that, I don't know if your other scenarios are going to get into this, but something I think I raised last week was if the marginal resource to set the energy price is either G1 or G2 at 90 or 80, which already includes its GHG cost, if we can look at a pricing outcome when that's the situation, because the GHG cost is embedded in the energy bids, which will then set the SMEC, but then potentially also have another GHG adder to it. If we can look at that at some point in time, I think that would be really useful. I'm not sure if one of your examples will show that, but if we can at least flag that.
So in these examples with a single generator in the greenhouse gas area, we won't be able to show this because to have this generator being cheap to be running, you will end up having export from the greenhouse gas area. So you won't have a marginal cost of greenhouse gas in area 1 if G1 is running. You're actually exporting from area 1. However, I know exactly what you want to show, and it would be possible if we had staggered bids in generation inside the area and outside the area so that you can have some bids selected inside the area, still not enough to meet the load, and you still get a greenhouse gas transfer to cover the rest. So now you may end up in a situation where you have a marginal greenhouse gas bid component inside the area because of the greenhouse gas transfer that you're getting in, and the marginal energy price potentially be set by an internal generator which has the greenhouse gas component implicit into the energy bid. I think that's what you want to show.
Yeah.
It may be possible. It requires a more complicated example. I don't think the setup for this example is sufficient to show that. It's going to be very complicated, right? Because you have to, once you have a generator inside being marginal, you won't have, the greenhouse gas transfer is not marginal anymore. So I'll have to see what the solution produces if you still have a marginal greenhouse gas component. You should. I'm saying you should because you have an attribution that you accepted, and that had a cost. So you have to pay it. So you must collect greenhouse gas revenue, which means that what I don't know, Kelly, is if you will still collect this as a price differential across the BAAs. We'll have to work together, maybe make a specific example to see how that plays out. We cannot do it with this example. There's not enough bids to stagger them for finding the solution inside area 1.
Okay, no, definitely, I appreciate that. Yeah, because I think having staggered bids is probably maybe a more realistic example, because here you have them all basically sequential to where the highest is inside the GHG area. But yeah, I can work with you offline to come up with that and look at the pricing implications. So, okay, thank you.
Thanks.
I do see a couple more callers in the queue. Please go ahead, the line is unmuted.
Hey, George. This is Alyssa Case-Weeder from Bonneville, and I have a educational question here. I may figure this out once I played around with the spreadsheet, but I didn't do that in advance, so I'm hoping maybe you can help me. So as you guys know, Bonneville sits in a situation where let's say roughly half of our balancing authority area, the load there is in Washington, and half of it is not. When you map this out, where are the generators, Bonneville's generators, sitting in this scenario, and how does that interplay with the power balance in between the two different zones, the GHG zone that would be within Bonneville's balancing area and the non-GHG zone?
Right. Thank you for the question. It's one problem we have to tackle to support Washington greenhouse gas area because of this peculiarity that it's only part of 3 BAAs actually. So what we were proposing to do is to separate the load, as I mentioned earlier. So the load of PPA in this case needs to be separated to load that is inside Washington, load that is outside Washington. Those loads will have a different LMP potentially. And for the generators, we have to also assign them to the greenhouse gas regulation area to Washington or not. And how we do that, it depends whether they're how they're located inside the state boundary or outside. So each node has a GPS coordinate, and then we can find out, or as a process of registering these resources, they can be declared to be inside the greenhouse gas regulation area or not. And that's important because if you're outside, like we saw in the example here, generator G3 is outside the greenhouse gas regulation area 1, still in BAA. And that allows the potential, which happened in this solution here, that G3 got 100 megawatt attribution. No, it didn't, sorry. If we look at G4, G4 did that. So G4 is outside the greenhouse gas regulation area 2, but both G2 and G4 are part of BAAB. But G4, because it's outside the greenhouse gas regulation area 2, can submit the greenhouse gas bid. That's the green bid there, 200 megawatts at $4. And it gets 130 megawatt of attribution into area 2. So it's important to very carefully distinguish the location of the generators in a BAA and separate or mark which are inside a greenhouse gas regulation area, which are outside, because they get different LMPs as well, and the ability to provide to get an attribution with this approach or not.
So George,
did I answer your?
Yeah. Sort of, but then there's under Washington's program, our understanding is that Bonneville's generators are not considered to be in-state generation. Even if they were, we've got dams that straddle state lines. And right. Those were all assigned to the non-GHG zone part of our balancing authority area. What does that do to the power balance in the part of our balancing authority area that's within the GHG zone, and does that have implications on this overall modeling?
It does. So essentially, you have a greenhouse gas regulation area, or let's call it the part of it that is inside BAA. Let's say for simplicity, it doesn't extend to other BAAs. Okay, so let's say Washington State is part of BPA. If all the generators in Washington State are considered out-of-state generators, okay, that means if you write the power balance constraint for Washington greenhouse gas regulation area, you'll find out that there is no generation, there's only load, therefore it has to be met with a greenhouse gas transfer from outside. So if you have what was in the example, 330 megawatt of load, you will have a 330 megawatt of greenhouse gas transfer. The solution cannot find out any other outcome. So it's forcing the optimal solution to get a 330 megawatt transfer. That has implications. It could be optimal because it will still be selecting, the model will still select the cheapest greenhouse gas bids to fill in that transfer. But if, for example, you don't have cheap greenhouse gas bids, it will still select the cheapest to fill that 330 megawatt transfer because there's no internal generator to provide supply. So in a hypothetical scenario that you have high greenhouse gas bids, that transfer is going to be expensive, although optimal. So there are implications.
Is it possible for you or us to take this model and model it in that way, George? I think it's really important to understand that because it's a real world impact that we are going to see from this.
When we build these toy models, and I emphasize toy because it's a small system with very few generators, the capability of the model is really not sufficient to model real world situations, and we don't recommend that. You really need bigger tools. The optimization has very few avenues for reaching the optimal solution here because there are very few variables. So the more constraints you put and the more changes you do to the model, like moving generator outside of greenhouse gas area outside, it strands the optimization makes it difficult to find a solution. Difficult meaning it's going to be more expensive solution. And I think when we go to the point where we try some scenarios that Mark Holman was suggesting earlier, well, you will see this playing out in the small model because it's very small. There aren't too many liberties for the organization to find a solution. So you may see outcomes that you don't expect. I think probably Mark Holman was referring to these outcomes. So I don't recommend using a simple model like this for studying real world problems. It's only for examples to understand how things work.
Do you have a suggestion then for better understanding that? Because it does concern me that we would have no generation on the Washington side of our balancing authority area.
As I said, your load in Washington is going to be met by greenhouse gas transfer from outside with the assumption, let's say, first of all, that we will end up having the resource-specific approach because that's about what we're talking about. In the resource-specific approach, you have voluntary submission of greenhouse gas bids. There's sufficient incentive for resources outside the greenhouse gas area to bid, right? Because they have extra revenue. So what we have seen in EIM today, there are sufficient greenhouse gas bids to make this problem not a serious problem. You're always having enough bids to have a greenhouse gas transfer to meet your load. So my assumption is that you're going to have sufficient greenhouse gas bids so that it doesn't matter that you don't have generator inside. All your supply is going to come from outside through a greenhouse gas transfer. And I expect it to be competitive because we select the cheapest greenhouse gas bids without applying constraints, transmission constraints. So it's an accounting problem. We haven't seen a problem like that in EIM, that you have an expensive transfer because of lack of greenhouse gas bids or expensive. You can't have expensive greenhouse gas bids either because we cap them, right? We cap them to what is expected to be the true emission cost, right?
Yeah, it's just that the resources being deemed aren't necessarily coming from the other side of our balancing authority area. Okay, I need to think about this a little bit more, George. We may need to have a follow-up conversation with you guys on it.
Sure.
Thank you.
You're welcome. Any more questions?
Yes, I do see one more caller in the queue. Please go ahead, your line is unmuted.
Hi, George. It's Mark Holman, and I appreciated your comments there. Certainly, in an Excel solver, we can't do everything in the real world, but I think we can show some realistic examples both for this and for the zonal. And in some ways, in the real world, if you have a flaw in an algorithm or a design, it actually gets much worse because there's a lot more generators that have base schedules and headroom that can be deemed delivered when they're now actually increasing their production above the counterfactual. I can't stay for the whole call. I could show you really quickly here, I think in 5 minutes with your existing example and changing a few numbers, what would happen and what we're seeing, in the actual outcomes in the EIM, if that's okay with you. I'm just concerned we're not going to get to it, and I think stakeholders will find it quite insightful.
Here for the resource-specific example, Mark?
Yeah, for the resource-specific example, just changing a handful of numbers to get it a little bit more consistent with the prices and the outcomes that we're seeing. I could walk you through it.
Let me copy it over.
Sorry?
Let me copy it over.
Yeah, so maybe I'll just say, if you change load 5 to 700 megawatts in both D and E 14, so that
just give me a second. Let me copy the
Excel sheet.
Don't change the numbers.
Oh, perfect. Thank you.
Okay. So what I'm going to change here?
Yeah, thanks so much for indulging me. If you take cells D and E14, so the load in BAC, and change that to 700 megawatts instead of 400. So we can see that BA has 800 megawatts of internal generation, and now it's got a load of 700. Now, if we change G8 to $65 instead of $50, so that it's right in between the higher emitting resources at G3 and G4. And then if we just change
like
the GHG, yes, and then just GHG prices will be the last one. So if we put G3 at $30, you know, typical what we'd see for a coal plant today, and maybe G4 at 28.
For both areas, right?
Yes, for both areas. We'll keep it nice and simple.
Okay.
And then if you make, and then G4 is $28. We'll just make it a little bit different. I mean, we could pick a number, 32, 28, whatever you want. Let's do 28. So it's a little bit more efficient, a little bit less emitting coal. And then if we just make the other GHG numbers $0, it's all hydro or hydro. And so if we just make those 0.
I'm sorry, I'm working on my part.
You're going too fast. I appreciate it.
And also G8, right?
Yes. And so what we've got here now, just to help highlight stakeholders, is G1 is $90. It's inside greenhouse gas area 1. So let's say that's California. G2 is $80. It's inside greenhouse gas 2. So let's say that's Washington. G3 and 4 are outside and they're coal. And let's assume G5 through 8 are hydro in Oregon with a 700 megawatt load. Yeah. So they're outside of the GHG pricing and they're all 0. Now, can you run the solver and we'll just see what the results are? And we did this really quickly, so I'm not sure it'll work here on your new sheet, but.
I just need to make a change.
Yes, it's right on the sensitivity report. Can you just point your cell down there to the right sensitivity report? Okay, now we have the results, George. So we can see that in California, you know, the BAA, it has 110 megawatts of load, but it didn't generate anything inside. So it must have imported that 110 megawatts, correct?
And that's what this is. Yep.
And then generator 2 inside Washington was the only Washington generator. It ran at 130, but had 330 of load. So it imported 200 megawatts. Okay.
This is the attribution from G8.
Okay. If we go down to the Oregon generation, we ran 800 megawatts of hydro with 700 megawatts of load. So BAC Oregon is only exporting 100 megawatts. It ran 700 megawatts of its hydro to serve its load, and it exported 100 megawatts only. What made up that difference of 110 megawatts to California and 200 megawatts to Washington was G3 and G4, coal. But the algorithm says, no, we're going to deem all of the supply to come from the Oregon hydro G6 and G8. And it actually deems 310 megawatts of hydro to be delivered, 110 to California, 200 to Washington, when Oregon's only generating 100 megawatts of hydro above its load and only exporting 100 megawatts.
That's right.
And so this is the problem of it dispatching coal and deeming it to come from hydro that is counterfactual hydro, that it's hydro that is serving load. Now, the last thing I wanted to show you, because I don't want to take up too much of the time, is if you go down to the prices.
Before you go there, the prices,
yeah, please.
Can we are aware of this problem. We have discussed it before, even with you, Mark. This is because there's no constraint that limits the attributions out of the AA. If you recall, and Anya had made a presentation on this recently, but we have made presentations on this several times. We have a proposal as part of the resource-specific approach to include a constraint that limits the total attribution out of the area, which area C here has a total attribution of 310 megawatts, right? Yes. To limit it to its export, which is 100 megawatts. So if you impose that constraint, you wouldn't have this phenomenon that you see here, which
I will come back to that. George, I will come back to that and explain why that constraint doesn't actually work, because you can have a BA that will dispatch the coal in the BA and deem it to come from its counterfactual hydro in the same BA. And so we can show that example too. I'm just trying to work with your example and show what this does. We can talk about your additional constraints, your import constraint, your export constraint, and where the gaps are in that. But maybe we should continue this example. I'm happy to set up a more complicated example that includes the constraints that aren't in your solver if you'd like. But I don't think that we can do that here today.
Okay. I mean, that suffices here. Then you wanted to show me something about the prices.
Yeah. So if you see the prices now, you can see that the price for serving 1 more megawatt of load in California is $70. Outside of California and Washington is 70, and in Washington is 80. So Bay Area 1, the LMP is $70. I'll show you why it says it's $70. If you go up, you'll see what it does. It sees that even though there's no more hydro that can serve load, the only options it should see is increased gas at $90 in California, increase the $80 G2 in Washington and send it to California, or increase the 270 megawatts of coal to 300 at $100, $70 generation, $30 fuel. But what the algorithm actually sees is that it can increase that coal 270 to 271 megawatts at $70 and deem 1 more megawatt to come from hydro. And this is the mix and match that we see.
Of course.
It dispatches one resource, but deems a different one. I was happy to hear about the export constraint as a concept, but the problem with an export constraint is the BAs that have a mix of coal and hydro, they're still going to find that their coal can get dispatched above the counterfactual, and then the hydro in the same BA gets deemed delivered that was counterfactual hydro, because you'll see 1 more megawatt export and the algorithm will still want to go and say, no, let's take that from the hydro. We're not going to worry about which resource increased its output above the counterfactual. And I think that is the critical flaw that we're trying to address through the zonal with a resource specific that only allows the incremental output to be deemed, not this mix and match approach.
You're describing a resource shuffling, aren't you?
I'm sorry, say that again, George?
It seems that you're describing a resource shuffling. So you have a 1 megawatt additional hydro deeming, which is backfilled by coal, right? That's what you're describing.
Yeah, but the hydro's not getting dispatched and backfilled. It's already at its maximum. But what this solution's saying is, let's just deem another megawatt to come from the existing hydro that's already running, but incrementally dispatch the coal. And that's the problem. I don't see it as backfill or secondary dispatch. I see it as we've got no link in the software between which resources increase their production and which resources get deemed delivered. And that's the gap that we see as a critical flaw with the resource specific.
Well, we have considered the fact that there is some backfilling occurring on the deeming. The deeming is done on a on a least cost basis using the greenhouse gas bids, and we know that there is backfilling, and I think this is what you're describing, Mark, but this is a known concept, and that is
George,
why
wouldn't we be better off here to run the gas? Like what it's showing here, and this is what we're seeing in the real world, that coal is $100 according to California's program. It's $70 plus $30 emissions. The right solution is to run the $90 gas and not import the coal. But the algorithm is saying, no, we can dispatch the coal and deem it to come from hydro, and that's least cost. That is not consistent with what we would expect to happen under the cap and trade program or the cap and invest. We want to run more gas than coal when the coal's emissions costs make it uneconomic. And it's not doing that. It's letting external coal displace internal gas.
Okay, so you say G1 is internal gas, but it's expensive. It's at $90.
But the coal is
still optimized, right?
The coal is $100. It's 70 plus 30.
Well, but the dimming is not going on the 30, it's going on the hydro.
That's the problem.
So
it sees the coal as a clean resource. It says I can take more coal at 70 and deem it to come from hydro at 0. And so the software
that's because of the backfilling. We know this method gets the cheapest deeming, and
George,
then
if there's one more megawatt of load, what do you think happens? The coal will go up to 271, and the hydro will get deemed by 1 more megawatt. And that is because there's no backfill. The hydro didn't increase its output and get backfilled. It was already running at maximum. All we did was dispatch the coal and deem it to come from hydro.
I'm noticing you've got a lot of folks in the queue.
I appreciate the time, and I really appreciate you giving me the space to be able to describe this example, George, because this is exactly the type of stakeholder dialogue we need to have to implement these very important programs accurately. So thanks so much. I'll let you move on.
Thank you.
Sure. So some of this conversation's resulted in some questions in the queue regarding the constraints, the net transfer constraints, and as well as what is reflected in the model, particularly in columns O and P. And there's also a question on making the equations available. So go ahead, George. And then we'll move on to the other callers in queue.
Okay, so there's a question on columns O and P, what these columns do. Let's explain this. I think I did mention it before. So column O is the constraint on the greenhouse gas attribution, which keys off the greenhouse gas reference. It's basically limiting the attribution to the difference between the upper economic limit and the greenhouse gas reference, right? You can see that the greenhouse gas reference is part of this constraint. The column P is a constraint that limits the attribution to the energy schedule, the 100 megawatts in this case. We don't attribute more than what is scheduled. So these are the two constraints that limit the greenhouse gas attribution and implicitly limit the greenhouse gas transfers, of course. The constraint that I was describing to Mark in our discussion about limiting further the aggregate attribution out of the PAA based on the export that PAA has, we don't have it in this model. It's a complicated constraint that I have not included in the model. It would have been too complicated to add it. Next question.
I think that's an important clarification. Thanks. The other question that came up is just making the model, or excuse me, the equations available for stakeholders in terms of the mathematical formulation.
It's all down here. I mean, it's in the solver. You saw it when I tried to run it. First of all, you must have the solver enabled in your Excel version. And then if you kick it up here, these are all the constraints, right? You see subject to constraints and list all the constraints. This is the models. I have saved it in each tab at the bottom. it's these constraints here are rows 65 to 77. So if you look at those, these are the various constraints, right? So each tab, depending on which model is solving, you have different constraints. And these are the constraints in the model. You can see them in the solver when you load it. These constraints are in it. And you can go through them and see what specifically what the constraints are, or you can see them in the solver as you try to run it. So if you try to run it, you'll see it has the control variables. This is the row that says by changing variable cells, B29 is your objective. And then you have the list of all the constraints, equality and inequality constraints, they're all there. So that's how you can go and see what the solver is actually solving, right? Any other questions?
I think we've got many callers in the queue. Go ahead.
Yeah, can we go to Tong Wu?
Sure. Sure. Please go ahead. Your line is unmuted.
I have just a clarification question. When you have
Tong, actually cannot hear you well. Can you please come a little closer to your mic?
Hello?
Tong, please, please go ahead. Tong, we cannot hear you again. So if you're having audio issues, you can please put your question in the chat to all panelists. And you can try to reconnect your audio as well. Anya, can I move to the next caller in the queue?
Yes, and then let's come back to Tom. Let's go with Petra.
Okay, sure. Please go ahead. Your line is unmuted.
Hello, can you
Peter,
hear me?
please go ahead. Your line is unmuted. Yes, please go ahead.
Yes.
Hey, George, to follow up on examples that Mark Holman was discussing, it's really good exercise, but I would like to remind all of us that even in EAM today, you're using GHG reference. Is that correct?
Yes, yes.
And if you use examples that just Mark Holman was discussing and set up GHG reference, and I just run it myself, you will see results that are not as critical and concerning as Mark Holman was discussing. So I would highly recommend that PowerX or anybody else in advance sends to everybody what modification in these edge cases they want to have so people can see what's going on. And it's really not practical to discuss setup that is not realistic to what is currently in the system and what is planned for EDAM. Not talking about export constraint, just simple GHG reference that you have. If you run the same example with counterfactual, which would be individual BA optimization, which you can very easily derive out of these prices, you will see quite different results. Thank you.
We can probably do it right now.
Yeah, it's very simple. You can figure out all this hydro in this 700 is going 200, 200, 200, 100. You can set reference and rerun it, and you will see quite different results. And then I would like to hear from PowerX. Yeah. Do they still have the same concerns like Holman was talking about at length previously? Thank you.
Now you made me curious. I want to run it. 300. What's our balance? What we need more? The load in BAA is, to go to the left. So what we have is, they're all 400, right? So we have, that will be tight for C, 300 for B. So we need another 100 for B. So that will be 100. All right. And then A is 400. So we're going to run this to 300. And this at 100.
Exactly.
So that's our reference, right?
Yes. Yes. Very simple
this?
reference. When you do individual BAs optimization, like on their own, you have a reference. And again, if you have another BAD, which is non-GHG, you can see even more interesting scenarios, and they will be very realistic. You really don't need big stuff to worry about. Plus, you have some stuff in optimization in the market software that take care of edge cases, to just mention that unique pricing that we didn't get to talk about yet.
Well, let's see what the results are with the reference. Obviously, we have much less attribution. Only G8, it has room for 100 megawatt of attribution, 72.1, 32.2. So your greenhouse gas transfers are 70 and 30 megawatts. That limits the attribution, so limits also the backfill I was referring to. Price is $90. That's correct, because you have $20 and 70 outside. So let's see. These are marginal. So
it would be good to analyze this scenario to see, do we still have a problem? I didn't have time to think about that, obviously, but PowerX can do this offline because they spend all the time on these things. To figure out, do we still have a problem? How big is the problem? And in addition to this, there are other changes we can make. We discussed this in the past. You can introduce special constraints, which are binary constraints, and I know you don't like that, but they may not be very expensive, that you permanently prevent any allocation below a counterfactual reference point. You just put simple binary constraint on top of that, and then you eliminate all the discussions about the wrong allocation. And contrary to expectation that if you have more binary variables, they're going to slow down solution, doesn't work always like that. Sometimes you add additional binaries and they reduce search space, and actually you solve the problem faster. So if you really have more concerns about this, you can go even that route and see what's going on. Thanks.
Yes, Peter, let me answer to Peter, because the issue is not really the binary variables. Of course, we can introduce them. There are other problems with this formulation with the binary variable. We link the reference to the optimal solution, so now the optimization can find a solution that users in the area 0, in the area without greenhouse gas regulation, can be uneconomically dispatched because it can give it room to get an attribution for serving load in the greenhouse gas regulation area. So essentially, all of the overall solution is optimal. You achieve overall optimality. There's a shifting between the load inside the greenhouse gas regulation area and the load outside the greenhouse gas regulation area. So you achieve a solution that gets a lower cost for serving the load inside the greenhouse gas regulation area at the expense of serving load outside the greenhouse gas regulation area. We have seen this in our simulations, and we don't believe it's a correct optimal solution that we should be seeking, because essentially we're compromising the optimality for serving external load to have a lower cost solution for the load inside the greenhouse gas regulation area. So that's why we didn't follow that approach, not because we're introducing binary variables. Thank you. Let's see the next question.
Yeah, so I see Mark Holman from PowerX in the queue, so let's unmute Mark's line so he can respond.
I really appreciate that, Isabella, and I think that was a good comment by Peter. And so the one thing I will say about GHG reference, you didn't have anything in there that GHG reference is really used, as I understand in your Excel model, to limit it to the headroom. But it wouldn't apply in this example if G8 had additional bids on it at higher price levels. Now, your example, of course, has to be simple, George, because it's Excel, as you point out, you can't do the real world. But actual hydro resources will have multiple steps, just as other resources will, multiple PQ steps. So if G8 had another 500 megawatts offered at $100, it wouldn't get dispatched, but it would make the headroom constraint meaningless. And in practice, there's thousands and thousands of megawatts of hydro with base schedules and with headroom. So those constraints don't bind in many occurrences. What actually happens is you dispatch the thermals and deem the counterfactual megawatts. That's not a criticism of anyone. That's a criticism of the algorithm and not having a link. And what we're seeing in practice, and we've gone through the data, is we're seeing thermals producing coal and gas and being exported when California is importing. It's displacing internal gas, and the GHG shadow price is low. So we know this is occurring, and it's occurring systemically. I really appreciate the opportunity to respond. I think Petter's last comment hit the nail on the head. You need to have a link between the resources that get identified as the specific resources supporting the import and the resources that are actually incrementally dispatched. Having software that says, I'm going to dispatch a thermal and I'm going to deem it to come from hydro that was running anyways, in our view, is so counter to the goals of GHG pricing programs, it certainly shouldn't be extended to a day-ahead market. So again, thanks for the opportunity and the time.
Thank you, Mark.
Okay, let's go to Stuart Kelly.
Thank you. And I recognize the issues that Mark Holman is raising regarding deeming, and that's why LA put together its proposal to address the deeming concerns, and I believe it does fully address the deeming concerns because there is no deeming. As a result, there's no leakage that accounts for secondary dispatch, and indeed has the reference point. So I think it addresses all of the concerns, and I think, George, when you get to that LA proposal, you can use the same data, you will get the same output. As regards the linkage, or the way I look at it to maybe Mark's other concern, it's either a linkage or it's, you know, effectively what I've suggested in the past, and that is put a GHG bid adder on all resources, but don't settle it. So thank you.
Thanks, Stuart. Hopefully we'll get to that tab. Any other questions?
I do not see any other callers. So I do not see any other callers in the queue. I'm sorry, just now a caller came into the queue. Please go ahead.
George, me back again. So I would really like us to focus analyzing this case to figure out, do we still have a problem? And not to kind of move the goalpost and start talking about multi-segment price curves and reference point. By the way, there is no problem with multi-segment price curve stepwise for this discussion that Holman mentioned. Not at all, because how program does is going to automatically switch up there, and because of unique pricing, we'll not have a problem of multiple prices for vertical segments. So it's really very important to look. It's very important to look into this case and say, do we still have a problem of allocation? Because even in LA approach is just changing settlement, and settlement is driven by GHG prices that are driven by allocation, because GHG prices are indirect results of allocation. So moving to load accounting, if GHG allocation is wrong, then GHG marginal prices will be wrong too. So settlement accounting in load accounting will be wrong too. So we really have to hit the bottom of this. Is this resource approach producing the result that is expected using correct counterfactual we can agree about. And here everybody like Holman and PowerX and other people who analyze this, is this what we see in this example or any other example they can raise, expected result or not? And if not, why not? Which numbers are showing here not to be as expected?
Yeah, I think the comment from Mark was that it was countering my comment earlier that was a response to you that by considering a greenhouse gas reference, you limit the attribution. So whatever problem you might have without a greenhouse gas reference, it's reduced because you have a lower attribution now because it's constrained. Like in this example, we went to 70 to 30 compared to the numbers before. But Mark was saying, you know, in reality, you have so much hydro that even if you limit the attribution with some greenhouse gas reference, there's still a lot of headroom on the hydro that's running that you still have the same effect. The constraint on the greenhouse gas reference doesn't really practically limit the attribution. That's what I understood from Mark's comment, the last one.
But in this case, you see hydro, the last one, is properly attributed, right? And I think the price, can you scroll down? What is the GHG marginal price? Should be 0. Can you scroll down?
Because it's only hydro that is. Well,
so why is GHG marginal price 20?
Because you have a $90 resource that is running, and it can make the difference in the greenhouse gas. So you see this guy here. This guy's a $90 resource. So because of the interaction of the energy and the greenhouse gas cost that you optimize, this resource that is running at 90, although the price is set $70 for the BAA, this resource is running at 90, so the difference is made up as a greenhouse gas regulation cost. We've seen this in other examples too. So that's
but
why
you see, George,
90.
if you analyze the numbers, you're getting 100 megawatts of hydro at 0, and there is no secondary dispatch in BAAC. There is no emitting resource, being increased in area C to substitute that 100 that is exported. So you really need to analyze this and see what's going on and why prices are the way it should be, because my expectation in this case, GHG marginal price would be 0.
Not in this case, the way we solved it here, Peter. It's, the math is correct, right? The model is working. You do get $20 as I mentioned, because this G1 is running at $90, needs to be paid $90. So that's, if $70 is the price of the marginal energy cost, there's a $20 marginal greenhouse gas cost that makes it to 90. I mean, it's there is an interaction, a close interaction between the energy and the greenhouse gas transfer. So you have that effect. It's similar to congestion, right? You may have a resource that its local LNP is higher because it contributes to relieving congestion compared to the system marginal energy cost, which is lower because it gets a greenhouse gas, in this case, a marginal congestion component added to the energy cost to get LNP. It's a very similar phenomenon here. But we have this solution here, and I agree with you that it will be useful to analyze it. But not on this call. I'm not prepared to do the analysis here on the fly.
Absolutely, we need more time offline. I'm sorry, I'm not expecting this call.
Yeah,
doesn't make sense. Sorry, thanks.
Thank you.
So, back to you, George. There are no more callers in the queue.
All right. So we saw the resource-specific approach, how it's implemented in this model. We are going to move next to the zonal approach. at least my interpretation of the zonal approach, where there is no dimming, there is no resource-specific greenhouse gas attribution. It's generic. This 110 and 330, excuse me, is for the area zero attribution generically or in aggregate, if you wish, to greenhouse gas area 1, and the same 330 aggregated to greenhouse gas area 2. You don't have greenhouse gas bids, okay, so you won't see resource-specific bids in the zonal approach. What you have is a hurdle rate. You have a hurdle rate for area 1 and a hurdle rate for area 2, and that's the cost for any greenhouse gas transfer that is going to be scheduled to these areas. And as we mentioned in the previous work group, I intentionally selected the hurdle rate to be $1 and $4 because this is what was the marginal greenhouse gas cost as a result of the resource-specific approach. So we have a comparable example here, how you would solve it with the zonal approach and the same solution. Of course, this will give you the same solution, but you have a 110 greenhouse gas transfer to area 1 and 330 to area 3, area 2. And of course, the prices are $1 and $4, which is your hurdle rate. So you get the same LMPs as before, 71 for area 1, 74 for area 2. The settlement is different though than the resource-specific approach because we don't have attributions and we don't pay the attributions. Simply the market operator collects greenhouse gas transfer revenue. So if you do the energy settlement here on column I, you'll see that there is a net 1430 revenue. All right. So 110 comes from the greenhouse gas transfer into area 1 and 1320 from the greenhouse gas transfer into area 2. Same as in the resource-specific approach because we used this specific hurdle rates. So you have the same outcome. However, we don't turn around now in the zonal approach and we pay generators for the attribution. There are no attributions. Essentially, this greenhouse gas transfer revenue is either allocated to loads or we give them to the regulator for each area to pursue their approach according to the regulation of how they want to disperse it. So the market operator is still revenue neutral. The resources are still paid adequately. They're paid only the energy cost. This is the zonal approach. Again, I'm only going to mention here, we still have a constraint in the zonal approach that limits the generic attribution to the generic schedule. So again, we don't attribute in aggregate more than what in aggregate the resources in area 0 are scheduled for. So this constraint is still there. So, and I want to emphasize that in general, your zonal approach will have a different solution from the resource-specific approach because it really depends on what you select for the hurdle rates. Here, I have the same solution because I intentionally selected those hurdle rates. Now, Mark Holman mentioned that the zonal approach, the way he sees it, it has some resource-specific attributes, which obviously I don't have that here. I solve the zonal approach as if there are no resource-specific attributes. If we are to assume certain resource-specific attributes, then I don't see a difference between the zonal approach and what we're going to discuss next, being a version of a hybrid approach that uses resource attribution for getting the solution and using the zonal settlement following up to that. So my understanding of the zonal approach is you don't have any dimming, you don't have resource-specific attributions, you solve it generically like that as if the hurdle rate is like the unspecified rate into a greenhouse gas regulation area. Well, let me stop here for questions and comments. Thank you.
Do we have any questions in the queue?
Yes, I do see one caller. Please go ahead. Your line is unmuted.
Hi, George. It's Mark Holman. I'll be quick on the zonal. I think the concept we're thinking about is you have resource specific, but the quantity is limited to incremental output above some base amount. So that could be your counterfactual, for example. So if you ran your counterfactual and you said, look, 700 megawatts of 800 is what would run, even if it's 700 of 2000, then the actual resource specific is more constrained than what your EIM deeming algorithm does and what your proposed EDAM does, because it doesn't just say incremental headroom, it limits it to the incremental output. But if you shrink the resource specific pool down just to the quantity that is actually incremental output beyond the reference level or counterfactual, that is why you also want the unspecified bucket so that all of the other resources can come in, even if they're not willing to be deemed, and so that you're not limiting the imports just to the resource specific, where the entity is taking on the reporting and compliance obligation and it reflects incremental output that is deliverable. You've also got the ability for those states to import all of the resources in a second category as unspecified that we see working well outside the EIM and proposed EDAM for many years now. And so think of it more of resource specific, where we've actually limited it to qualifying resource specific in a different way, and then adding a second bucket of allowing unspecified imports. One of the challenges that was highlighted earlier is that currently in the software, as I understand it, the total imports that California could get, or California and Washington, is limited by the aggregate amount of deeming. And if we constrained what resources can be deemed or can be resource specific to a smaller amount that reflects incremental output that's deliverable, then that constraint might get concerning, that we run out of resources that can come in resource specific, and now those states can't import anymore. So I just want you to think about, it is not helpful to call one resource specific and one zonal. I know those names have caught on, but I think about the current one as one way to try to do resource specific with deeming. This is a different way to have two categories, resource specific and unspecified, but the resource specific creates that link to make sure that what we're bringing in as resource specific is truly incremental output. We're not dispatching the thermal and deeming counterfactual megawatts from clean. Again, I'll let you move on because I know there's only so much time, but I just wanted to share the concept. I do appreciate you taking a crack at trying to set up the workbook. Happy to take it offline and try to send you a modified workbook that does the concept that I just described. So thanks again.
I think it will be helpful, Mark, if you provide a similar tool or maybe a tab. If you can describe the zonal approach in the example setup that we have here, so that we can understand what you mean. It sounded very complicated the way you described it. Maybe certainly a lot more complicated than what I have here. It sounded like a version of the reverse specific approach.
Instead of having one hurdle rate for all the resources going into GHG Area 1 and one hurdle rate for all the resources into GHG 2, and by the way, that might be $14 or $16 something like that based on today's GHG prices, the resources that are resource specific would have their own resource specific hurdle rate. And so it's not going to have a change to your model, but when you get into implementation, you have to define the rules of what qualifies a resource to be resource specific and not fall into the unspecified bucket. And so it's not that big of a change in terms of what you're trying to illustrate here, George, but again, I'll let you move on.
Thank you. Okay.
Sorry, Mark, before you drop off. Sorry, Mark, before you drop off, a question came up just in terms of kind of the policy clarification around resource specific within zonal. There's a question that came in: if a resource defines itself as resource specific, can they also be dispatched in the non-GHG zone? And that question is for Mark Holman.
Thanks. Sorry, I was muted. Yes, and I think that's the details that would be worked through. Is I would expect all resources are available to serve load outside, and then resources that are resource specific can also be available to be dispatched to get to the GHG zone as resource specific, but they would have to meet certain criteria. What is in addition to that is all resources that were not either eligible or chose to be resource specific could also be imported as unspecified. And so that gives you a bigger pool of resources for Washington and California as an example. But yes, and that's something that we would love to work through in terms of how do you make sure that the resource specific qualifications are appropriate, not over constraining, but also not including megawatts that are not deliverable or non-incremental production. And then how do we do that in a way that also makes sure that those resources are available to serve load outside? And, you know, part of that could be, and I'm not saying this is a solution, but could be what the CAISO has done for part of its resource-specific approach is you have a counterfactual. And the counterfactual makes all resources available to serve load outside. And so we would see it being available to both. I don't think we can work through all that policy today, and I don't want to take time away from everyone seeing George's Excel sheets and working through the examples.
Thanks, Mark. Let's move to Jeff Nelson next. Could we unmute Jeff's line?
Good afternoon, everybody. Jeff Nelson, SCE. So I don't want to misunderstand. I've got a sort of an understanding of how the zonal approach works, and I just want to make sure I'm not misunderstanding that there's a hurdle rate to go from a non-GHG area into a GHG area. That's sort of the rule, and the hurdle rate applies to all the generation in the non-GHG area. It may be different hurdles to different GHG areas, but every unit faces the hurdle going into a GHG area. So do I have that understanding so far correct as a rule?
That was my understanding, Jeff, too, and that's how I built this model. But hearing Mark Holman, he has a different understanding of what the zonal approach means, and maybe zonal is not a correct name anymore, but he was suggesting that essentially it is a resource-specific approach with specific rules that set the greenhouse gas bid price for resources, whether they're unspecified or specified. Or so it raised question in my mind why we call it zonal. It's really a version of the resource-specific approach, in which case I wonder why you won't see the same problems that he was exhibiting earlier with a resource-specific approach. If it's still a resource-specific approach, you still have the same fundamental problems of dimming hydro and getting it from carbon. I mean, it's like it's the same issue.
Yeah, well, I wanted to just expand on my understanding. Maybe it's wrong, but my understanding was that was the general rule. There's a single hurdle rate for everybody, and the exception to the rule is if you arrange transmission, you purchase transmission from your resource that's in a non-GHG zone into the GHG zone. If you buy transmission from someone, if you can find someone willing to sell you transmission, then you effectively become within the GHG zone and you don't face the hurdle anymore. That's kind of my understanding.
Let me jump in here for a moment. So as I understand the zonal proposal, any resource, kind of to your point on the exception to the hurdle, it's resources that qualify for being resource specific. And I have not heard in the discussions or in the proposals to date a requirement that there is transmission. Now, Mark, if you have kind of an update there or a suggestion, we're open to hearing that. But there has been that proposal all along to have that resource-specific pathway, and for resources that are not using the resource-specific pathway and being viewed as internal to the GHG regulation area, they would need to overcome the toll.
Right. So, but I understood
pathway. For the hurdle rate.
I understood pathway to mean just that. you had to have a path from your generation to the GHG region.
Jeff, are you referring to the concept that we were discussing before using the term greenhouse gas pseudo-tie?
I don't know what the Ldwp approach is proposing on how you get out of there to get special treatment. But the concern I have with this understanding is that let's just look at, let's just use me, for example. We have a clean resources within California, and I don't know if anyone's on from Nevada, but let's just pretend they are. And a clean resource from Nevada. And California needs more power, right? Let's just assume that, just a simple example. If that clean resource in Nevada faces this hurdle rate, isn't it being put at a structural, discriminatory, competitive disadvantage relative to the clean resource in California? You know, even if they're both bidding zero, the clean resource in Nevada is not going to be able to sell to California because of the hurdle rate. And my understanding is the only way they can get around that is become some sort of special resource. And again, maybe I misunderstand the proposal. The only way they become special is they have to buy transmission. So now to be able to compete on a level playing field, you first have to buy transmission from someone. And maybe I misunderstand, but it just seems like it's a fundamentally flawed approach. Sorry to use that term. And again, maybe I misunderstand.
Why it's fundamentally flawed? Jeff, I think I understand what you're saying, and this was my understanding too, but explain why it's fundamentally flawed. The fact that you're forced to buy transmission?
Yeah, in effect, you're discriminating against the person outside of the GHG zone relative to the person inside the GHG zone by market design. Because
if you don't buy transmission to become a greenhouse gas pseudo-tie, you'll be burdened with the hurdle rate.
Yes, and your competitor across the border is not burdened. Now, maybe I should keep my mouth shut because I'm in California or something, but just looking sort of at theoretical design, I can't get over that, pardon the pun, hurdle.
Yes, I mean, this was in our description as well, and our critique in the Ldwp proposal, but the zone approach, the way we understand it, like, you know, the two of us speak right now, we did point out that it's discriminatory for resources that have a lower emission intensity than the hurdle rate that will be used, unless they take this extra action that you mentioned, maybe by transmission, to become a greenhouse gas pseudo-tie. And we saw that as an additional, as a lift that you have to do to compete with internal resources. So you're right. We pointed those out too.
Okay, just again, maybe the proposal's evolved, and okay, because I'm stuck on that. And if it's evolved, that's great. I just need to understand how it's evolved. Thank you.
All right, moving on to next question.
Could we unmute Coleman's line?
Okay, please go ahead. The line is unmuted.
Hi, George. It's Mark Holman, and I appreciate Jeff Nelson's comment. I don't think it's helpful to, you know, jump to conclusions about discriminatory and you need to buy transmission and there might not be any available and that's discriminatory. I think we need to take a step back and talk about the different proposals and what they're trying to achieve. And I think it's been repeatedly described, both in writing and in workshops, that zonal has two different categories of imports, resource specific and unspecified. It's also been repeatedly described that resource specific does not face the unspecified hurdle rate. There is no hurdle rate or standardized hurdle rate for resource specific. It's their specific GHG rate. The work that needs to be done is what is the appropriate qualifications to allow a resource to be treated as resource specific under the zonal approach, and really under any approach. And I think there's some basic elements that I would hope we could all agree on. One is that should we be counting something as resource specific if it's already running to serve load in the counterfactual? Is it okay to dispatch some other resource, coal or gas, and deem it to come from a resource that would have ran at that level anyways to serve load outside? So we'd say, got to put in a requirement that limits that. Should we be including resources as resource specific and saying those are the resources that are imported, a hydro resource in the Northwest, when the transmission is all full, there's no way to get there, and we dispatch a resource in the Rockies or the Southwest? And so should there be a deliverability requirement? I think we need to work through what are the appropriate qualifications that are rational and reasonable, non-discriminatory, to allow resources to come in as resource specific at their GHG specific price, and make sure that we do enable those clean resources to participate in a non-discriminatory way and compete with internal resources, but we don't continue the path that we've been on, where we have such extensive misallocation that we're dispatching thermals and pretending or calling them clean resources, and we're getting bad outcomes. We're getting outcomes where higher priced, higher emitting external resources are displacing internal resources. And so I hope that as we continue this dialogue in the multiple forums on GHG pricing programs, that we can find solutions that adhere to reasonable and appropriate requirements for resource specific. Thanks.
Mark, can you stay on for a moment? I think
I've got to run to another call in 2 minutes, George. I really do apologize, and I've taken up a lot of airtime today. I'm happy to answer a quick question.
No, all I was going to say is that the problem that I see here is use of the term zonal approach when you really mean to have resource-specific attributions, and that's why we could not connect the dots. That's why I assumed that there's no resource-specific.
Thinking about we may have multiple states, i.e. multiple zones. We may have, that aren't linked. We're also thinking about how do you get...
Even in the first proposal that we saw about the zonal, it was only one zone where the greenhouse gas regulation areas were merged. Anyway, I think there have been changes.
I think I'm agreeing with you, George. I think the resource specific versus zonal is not very good naming to compare the two, and I think that's unfortunate.
But there's a way to clear this up. I think PowerX should take one of those examples that we're using here and illustrate to all of us how is your perception of the zonal approach would work, so that the rest of us could also understand it. Because right now, I don't have a complete understanding of what you mean by zonal. And I think you need to show it to us.
I think we're very happy to continue to work on this with PGP and with other stakeholders. I'm hoping that the documents that are already out there will help going back and doing a fresh read of those and seeing that there is both resource specific and unspecified. But I think also advancing that and working through examples in Excel and talking it through. And if we could just de-escalate the discussion around discriminatory, I think that would be really helpful to stakeholder dialogue, because we really are trying to get to a solution that is efficient, that is reliable, but that properly respects the goals of these GHG pricing programs.
Understood. Thank you for offering to provide an example to illustrate the approach and for all of us to understand it.
All right, let's go to the next caller. Looks like that's Kathleen.
Yes.
Hi, great, thanks. This is Kathleen Colbert from Vistra. I have some pretty high-level suggestions, since it sounds like we will be, or the CAISO and, maybe some partners flipping another version of this spreadsheet. One of the things that I think is a little slightly confusing in your zonal tab is that you have values in the greenhouse gas attribution area in 1 and 2 columns. I get that you did for simplicity and ease of the spreadsheet.
The 110. Oh, what happened?
No, go up. Just in general, you're using these columns, but this is the exact opposite of what. Yes. So like, it would be helpful when you flip a new spreadsheet to have another column with unspecified and show it separately. It really isn't an attribution.
It's all unspecified. It's all unspecified.
I know, but it doesn't.
What I was mentioning to Mark. But,
I understand that.
But it's.
I understand that, George. It just.
Yeah.
Does. Sorry, just I'm just trying to say that the name that it would just be easy for stakeholders who didn't benefit from this conversation who are looking at this spreadsheet, since you are going to flip a new one. Specified, it would be clearer that that's what this is. I know that's what this is based on the math, but if you showed it in a separate column and then called it unspecified for area 1 and unspecified for area 2, I think it would just be easier for stakeholders going back to this.
It's basically this column. You say instead of saying greenhouse gas attribution to area 1, you're suggesting to call it unspecified attribution to area 1?
Well,
you're
going to need to keep J and K, because a good way to do. So I'll be frank, I don't find it as complicated as I think I heard you guys talking about with source specified treatment. But I will echo what Mark said. It has been very well discussed that there's unspecified, source specified under the zonal approach. And frankly, it doesn't bother me and hasn't bothered me that there's a source specified treatment.
I agree.
So
it was discussed. It was never demonstrated through an example. And that's why I clearly asked Mark and PowerX to provide an example here to help us all. It has never been demonstrated, and I had a problem, even me, figuring out how to construct an example to show the zonal. So this is my interpretation. And it's not what he means. So he needs to show us what he meant.
That's fine. I would just clarify, George, it's not just Mark. It's not just PowerX that's been working on this design. And if you don't want feedback right now on this detail, then I will just extend an offer to PowerX to help them with that. I think this can be very easily flipped. And if what I'm suggesting is confusing without showing you exactly what it would look like, I think we can help you get that.
Okay, good, because I didn't understand what you were saying about adding another column. These are the columns that, these are control variables, right? So adding another column, I don't know what that means. Adding another variable to the problem. So maybe you can demonstrate, send me an email with what you think as a modification to this model. Clearly, this is not the zonal approach the way it's understood or proposed by PGP and PowerX. This is my interpretation that doesn't have any resource-specific attribution. So obviously, that's not it. You can consider it as another approach for solving a greenhouse gas regulation cost problem, but it's not the one that obviously was proposed with the resource-specific attributes that, we need more information and an example to see how it works.
And if I can just try to make my feedback simpler or more clear on my part, all I was really trying to bring up was actually a much more basic suggestion that since we just, what this like to me is you're saying that it's an attribution to G3 because it's only the row G3, but that's not accurate.
No,
we don't know where it's coming from.
Yeah.
Very basic feedback on how to represent it.
Yeah, no.
I get it.
Thank you, Kathleen.
I get what you're doing, George. I just.
No, I need to explain it now because I guess it appears on this row 4, the 110. But as you can see, I don't have separate cells. It's really, I wanted to merge all these cells so that, the 110 is really for all of the generators. It's an aggregate attribution. And I couldn't merge it because the solver model doesn't like the merged cells, so I couldn't solve with it. So I had to leave it unmerged, and it appears as being in row where the G3 is, but it's not the attribution for G3. It's an aggregate attribution for all of G3 through G8. Does that help?
Yeah, and it makes perfect sense to why you did what you did. I don't know if someone who isn't on this call would have got that, which is why I was suggesting maybe a note or changing the title to make it clear it's the entire group. Something just that helps others.
It's the aggregate attribution. That's what it is. So you're right. It appears as if it is attributed to G3, but that's not the case. Yeah. Thank you for pointing that out. Something else?
Yeah, could we go to Stuart Kelly next?
Yeah.
Yeah, just in terms of the source specific, one point I would make there, and maybe with the next iteration I'll understand it better. I don't see how self schedules don't work for that particular approach. So if PowerX could maybe bear that in mind in any updates to its documentation, that would help me tremendously, because I think you can accomplish getting that generation to a GHG zone with a self schedule, and obviously a lot of the times LA's got wind coming from the northwest and it already has transmission. So I'm failing to see some points or some elements there. When it comes to the unspecified component, I do echo Jeff's concerns. So another iteration may be helpful. But I also get concerned when we start to talk about restricting the generating pool and have transmission requirements. I think all that does is it undermines the market and market efficiency. It may cause other problems. I think this was similar to the discussion Doug Howe had, from the Oregon side, and just been able to elect to have renewables serve load. I think there's some considerations when you start to get down that path as we go through pretty much a transitioning phase here in the West. Maybe that's something that can consider long term. And then I think that the more critical aspect I have is that pool gets limited. I really worry about increased prices to the market as a whole. So that would be my general concerns.
Thanks, Stuart.
I do see a couple more callers in the queue.
Okay.
Yeah. Moving on to the next caller. Please go ahead. The line is unmuted.
Hi there. I believe that's me. This is Jessica Zano, Puget Sound Energy. I just want to kind of reiterate the support for de-escalating the language around discriminatory treatment. I mean, I think there could be a point made that the deeming methodology is in fact discriminatory in certain ways as well. So I think to Jeff's point, Spire's point, is that there is work to be done around finding the right levels for the hurdle rates, finding the right levels for the carbon prices applied to the resources within the GHG zone. But there are costs to resources within the GHG zone as well. They may not have the transmission costs, but there are costs applied to their dispatch stacks as well. And so just kind of finding the right level for all of those things, all those places, is important and critical. And, it's not perfect as well, but it doesn't necessarily need to be termed, discriminatory. Thank you.
I do not see any other callers in the queue.
Okay, thank you. All right, so I showed you the model, how it solves the example for the zonal approach, the way I interpreted it, that we presented last time. Let's move on to what we call the hybrid approach. And this is essentially.
George, just based on
yes.
limited time, do you mind if we, just recognizing we have limited time, do you mind if we start with the Ldwp approach and then move to hybrids?
We could, we'll go to introduce some constraints in the problem, because without a reference, the hybrid approach does not use a greenhouse gas reference, and without a reference, the Ldwp and the hybrid approach are the same. So we see the differences if we solve the problem with the greenhouse gas reference. So let's go to a problem that we have with the reference. I believe it's this one here. Let's see. Okay. So here we're solving the resource-specific approach having a greenhouse gas reference. That's the counterfactual. So it's the same problem that we had before, okay? Same bits that we showed before, okay? But we have a greenhouse gas reference here, which in column K, which essentially describes how each BAA could serve its own load without the benefit of transfers. So you can see that the 400 megawatt load in area C is served from generators G5 and G6, 7 and 8 are not running. And then the load in the BAAs A and B are served by 300 megawatts from the next cheaper generator, that's G3 and G4. And then generators G1 and G2 inside the greenhouse gas regulation area, so being the more expensive, they take the balance of the 100 megawatts, and that's your greenhouse gas reference. For resources inside the greenhouse gas regulation area, like G1 and G2, the reference is not important because the constraint that we formulate as a result of having a greenhouse gas reference affects only the attributions, and only resources in area 0 outside of the greenhouse gas regulation areas can have attributions. So therefore, it's the reference for generators G3 through G8 that matters. And comparing the solutions, you can see that this restriction that the greenhouse gas reference imposes on the attribution has the result to have a lower attribution. You still have a 110 attribution for G7, but the attribution for G8 is only 200 megawatts. So you only have a greenhouse gas transfer into area 2 of 200 instead of we had 330, I believe, because the load was 330. So that means that we still need to run a generator at 130 megawatt G2 to serve the load L2. All right. In the solution that we had without the reference, that generator was not running. We managed to displace it with greenhouse gas transfer, but now the greenhouse gas transfer is limited. So we have a higher cost solution, obviously, because we impose that restriction. If you compare this objective function with the one that we had in the resource-specific solution. And if we go down, we may have different prices as well. The marginal price is $60, all right? And we have marginal greenhouse gas costs for area 1, $2, and $20 for area 2, $20 for area 2, because when we synthesize the prices, you need to have an $80 price inside area 2 to pay adequately for that generator that runs at 130 megawatts with the energy bid of $80. So that's the resource-specific approach with the resource-specific settlement, which results in a greenhouse gas transfer revenue of $220 for area 1 and $4,000 for area 2, which is then dispersed to the greenhouse gas attributions. Now, the LDWP approach, which is a variant of the hybrid, essentially we try to solve the same problem. And in the LDWP approach, you still have the same greenhouse gas reference, but now the bids are not voluntary because there's no dimming and there's no reporting requirement for external resources. The market operator inserts a full bid, a full greenhouse gas bid. So all resources in area 0, they get a full greenhouse gas bid. I assume the same carbon cost here for the two greenhouse gas areas, so it's the same prices, but they could be different if the cost of carbon is different for the greenhouse gas areas. You still have the constraint of the greenhouse gas reference and potentially any other constraint that we have for the resource-specific approach, all right? So you still have a limitation on the attribution because of the greenhouse gas reference, but because you have all the possible bids that you could have for greenhouse gas, this is an easier problem to solve, so you reach a lower cost. So the cost is $54,400 compared to the $55,420, right? Because you have all the bids available, so you get higher attributions. The attribution for area 2 is 290 megawatts with this solution. Okay, it's still not 330 that we had without the greenhouse gas reference, but it's better than what we had with the resource-specific approach, which was 200. So now you can displace more of the expensive generator, which is now still has to run, but at 40 megawatts instead of 130 megawatts, because we can get these attributions into area 2 from generator 7 and 8. The solution is materially different too in the prices. We have $10 being the greenhouse gas, the marginal greenhouse gas cost for both transfers, and you need that to get to the $80 marginal price for the LMP for area 2, because that generator is running at $80. So the energy price plus the marginal greenhouse gas cost comes to the LMP that is payment adequate for the generator. The settlement is different for the LDWP approach and any variant of the hybrid approach. Instead, you still collect greenhouse gas transfer revenue, $1,100 for the greenhouse gas transfer into area 1, and $2,900 for the greenhouse gas transfer into area 2, but you don't pay any attributions now. This is dispersed to the loads in area 1 and area 2, or it's given to the regulators of the area 1 and area 2, similar to the zonal settlement. So the LDWP approach is a hybrid approach where you enforce or you apply the resource-specific methodology to find the optimal solution, subject to any set of constraints you want to consider for a resource-specific approach, like the greenhouse gas reference here, for example, and follows up with a zonal settlement of not paying any attributions, discard the attributions, and pay the load in the greenhouse gas regulation areas for the greenhouse gas transfer that is collected as a byproduct of the energy settlement. So let's see if there are any questions on this.
Yes, I do see a caller in the queue. Please go ahead, your line is unmuted.
George, can you hear me?
Yes.
So it's better. I think my understanding of LA approach is different. LA approach does not require mandatory GHG bids for all the resources. LA approach requires mandatory GHG bid adder for all the external resources who didn't opt out from selling to GHG zone. So from that aspect, it's absolutely identical, like resource-based. So the only people can bid everything, or they can bid whatever they, subset of that. So the only difference, in my understanding, as Stuart can correct me, is that settlement is exactly the same amount of money, except it's not allocated to resources. It is allocated to GHG areas, load in GHG areas. But everything else, bidding, partial bids, full bid, everything. Now, the other fundamental difference, and that's why it's very important, is that if you allocate to resources, then resources are incentivized to bid GHG bid because they'll be paid money. So if you are a renewable resource and you get marginal GHG for gas, and you buy some allocation, then you make money. In this approach, where money is not going to resources, some other entity has to enter GHG bids for resources that didn't opt out from bidding to GHG zones. So that's another difference between resource-specific and LA approach. But everything else, algorithm, dispatch, pricing, should be the same. That's my understanding. If I'm wrong, Stuart can correct me.
I hope Stuart can come in and clarify this, because if you don't have dimming and reporting requirements, why would you invite voluntary bids that can have a material impact on the solution without having any...
Because you have to treat external resources, equally situated external resources, the same way as internal. If you don't do that, then gas would be cheaper outside of California, be cheaper than gas in California, and that's not just and reasonable. So in order for markets to be properly designed, some entity, either CAISO or CARB, has to force people to register in master file and get GHG calculated properly for those who don't opt out. Otherwise, you'll be importing gas and coal for free. If they are economically competitive, whatever gas and coal, there is no coal in California, but whatever gas you have left in California, that gas will have a mandatory GHG cost in their bids. And if you don't force on similar resources who didn't opt out, the GHG bid either calculated properly, then you discriminate against, I have to use that word, discriminate against, let's say, gas resources in California.
Well, let's see if Stuart can come in and clarify this, and I'll take my arguments with him, because I have arguments against all that logic. I just can't see if there is no deeming and you don't pay any external resources. Why does external resources have optional bids that may materially affect the outcome? This shouldn't have any bid. We should put whatever cost is the true cost of the emission and run. I mean, this is the fundamental difference between a hybrid approach and the resource-specific approach. That resource-specific approach invites bids because people are getting paid for those bids. But here, there's no payment for the bid. Why would you invite any bid? I don't understand.
Well,
ask
CARB if CARB let outside emitting resources to enter California without a GHG bid either.
No, it's fundamentally different than the resource-specific approach, in that the resource-specific deeming here is only used as a tool. There is not going to be a reporting requirement for external resources. So definitely this requires some changes in CARB's regulation to go through. That's
George,
not,
if you don't have GHG bid adder on emitting resources and they are competitive, your marginal GHG cost will be zero for net import.
No, that's not what I'm saying, Pedro. No, that's not what I'm saying. See this, there are bids here, right? $5, $4, $1. Okay, so there are bids, but these bids are not submitted by the scheduling coordinator of the external resources. They're inserted by the market operator. That's a fundamental difference with the resource-specific approach.
Yeah,
and
that's
the
what
rationale for that.
Way. It has to be done that way.
Oh, we agree. You agree with me then? Because I thought.
No. But I said earlier, George. I explained earlier that if you don't do that, people are not going to enter GHG bids on their own because they're not paid money, and they will be more competitive in California if they don't add GHG bid adder. So somebody has to do it, not resources who didn't opt out from selling to California. We agree about that.
Okay. Okay, so we're violently agreeing then. I don't understand why you said about the, okay. I misunderstood what you said, but this is exactly what I'm showing here, that these bids are inserted by the market operators and not submitted by the external resource. So we agree on this, right?
Yeah, but they don't have to be inserted for everybody, as you said. That's the difference. They are inserted only for people who didn't opt out. For people who opt out from selling to GG zone, you cannot enter GG bid.
But these people don't have the right to opt out or opt in. They're not getting paid. They're not part of the settlement. They don't have a reporting requirement. We don't ask them whether they want to participate or not. We solve the problem reflecting the true emission costs. This is the essence of the hybrid approach, any version of the hybrid approach, including my understanding, the Ldwp approach. I hope Stuart can come in and clarify, because this is what I understood out of this.
Stuart is on the line if we want to unmute him.
Yes, please. In the meantime, I'm going to retrieve my stylus that fell on the floor.
George, you absolutely have a point, but the LA approach, as Peter described, it's almost like lay a foundation. It's like a baby step, and only consider the resources that want to bid into a GHG zone. I fully respect and understand your viewpoint. I think that's maybe something that the LA approach can gravitate to, potentially in the future if there's an appetite for that. But as a kind of pragmatist, and the outcome that we're seeking at the moment is absolutely equivalent to the resource specific as you described, with the same pricing, which that would only consider who bids in. And we're fundamentally trying to, get two objectives here with our approach, which were the main issues raised in the working groups, and that is move away from deeming, which we've accomplished, and free others from the obligation if they're not in the GHG zone. I do respect your point, but as I say, as a pragmatist, I just want equivalency with the resource specific, and to achieve both those outcomes. I think that lays a good foundation for further development and discussion with the agencies.
Thanks, sir. Just to clarify, the clarification if I may ask, you envision voluntary greenhouse gas bid adders for the Ldwp proposal?
Yeah, you would just indicate in cyber whether you want to bid into a GHG zone or not dissimilar to resource specific, and then the market operator would insert the bid adder.
Okay, so you have the option to participate or not, and if you participate, the market operator inserts the bid on your behalf.
Correct. Yes.
Okay.
It's just that there's bookends and different variations. I'm looking at the path of least resistance.
Gotcha. Okay. So what we're showing here is assuming that all generators in area C, G3 through all in area 0, so G3 through G8 are willing to participate, and then these bids are inserted by the market operator reflecting the true emission cost. Right? Okay. So the Ldwp proposal, then it's the resource-specific proposal with the zonal settlement. The only twist is that if resources participate, if resources in area 0 participate, they don't get to submit a greenhouse gas bid adder. The greenhouse gas bid adder is inserted based on the emission rate that they have registered in the master file and the carbon cost for the greenhouse gas area for which the bid is constructed. I got that right, Stuart? Okay. All right. So let's show the last one then, what we called, or I called, a hybrid approach, which we presented last time. So this problem here, with with a hybrid approach, we don't have any constraint limiting the greenhouse gas attribution. So we don't even consider the greenhouse gas reference. So if you look at the optimal solution here is 54,400. If we go to the hybrid approach, let's find out here. The same bids, they're all inserted by the market operator. Here there is no option to opt out, okay, in this approach. And there is no constraint on the greenhouse gas attribution, except the basic constraint that we don't attribute more than the schedule. That's still there, okay? The bids are still the same that you saw with the Ldwp proposal, assuming that all resources participate or show willingness to participate. Here it doesn't matter. They will all be made to participate because anyway, they don't get any dimming, they don't get any payments, so they have no say in how the market operator will calculate the optimal solution. And we ignore any greenhouse gas left. So we don't have a counterfactual here. The rationale behind the hybrid approach is that we don't care for leakage. That's not the responsibility of the market operator. The responsibility of the market operator is to find the least cost solution. And this is what it does. As you see, the cost from 44,400 was it? It's down to 53,280 because this is the lowest cost solution that you can find. And you can see that you can get the 330 megawatt of attribution to area 2 out of all these resources that participate. And you have the marginal cost of greenhouse gas regulation is $2. So you have a price $72 in the area 1 and 2 and $70 outside. We still don't have greenhouse gas transfers. We still have the zonal settlement, same as the Ldwp and zonal proposal, where essentially you, the market operator collects $880 of greenhouse gas transfer revenue, $220 for the transfer into area 1, $660 for the transfer into area 2, and this is paid to the loan. So the fundamental difference here is that this solution does not enforce any constraints in the attribution, so you get the lowest cost solution. And again, the rationale is that we don't care for leakage. That is addressed by the regulator exposed with the existing or suitably modified approach for capturing residual emissions. Let me open for questions.
George, for folks that aren't familiar with the hybrid, it's not one of the 3 proposals being discussed. Do you want to discuss why it's included in this modeling exercise?
Yeah. Basically, when we first heard the Ldwp proposal, we had thoughts of following the same path internally, and this one took it, I guess, to the extreme of maximizing or minimizing the overall cost without any restrictions to attributions. We think it's useful to present this as a potential approach. There are many ways that you can have hybrid approaches, as you already realized, depending on how much restriction you want to put on the attributions, whether you consider optionality for participating and all of that. And we think that this is another way of doing it that will really get you down to the most optimal solution in terms of optimizing energy and greenhouse gas regulation costs.
I do see a caller in the queue. Please go ahead, your line is unmuted.
Good afternoon, Jeff Nelson again from SCE. So I guess the question is for George. I think it's true for both the LA and the hybrid that I'm just going to look from California shoes. Our prices are still going to reflect, if we're getting transfers, sort of the cost of both the energy and the GHG associated with that transfer, right? So I don't know, I'm not sure exactly marginal of both or the least cost combination of those. So you'll actually collect more money from California load than you'll pay the external generators under both of these. Is that correct? Assuming a GHG transfer, assuming a transfer that's got GHG intensity.
Yes. So the LMP inside the greenhouse gas regulation area has an additional component, the marginal greenhouse gas regulation cost. So the load pays that higher LMP, but then it also receives the greenhouse gas transfer revenue, which offsets the cost for the import. But because you're using a marginal cost for the energy, there is a higher cost for that energy because we settle at the marginal cost, not only at some average cost that you would have if you say, well, we have 500 megawatts loads, 300 imports, so you have 200 at the internal price plus 300 with the additional cost. You have some average cost. We settle at the marginal cost. So the LMP is including that greenhouse gas marginal cost component.
Right. And just again, I'm just trying to make sure I understand all the mechanics. And under both the LA and the hybrid, the external generators no longer have any CARB compliance requirement. They're not getting paid this premium.
Absolutely not.
And they have no longer a requirement.
Yes.
But instead, there's some flavor of GHG intensity that is allocated to the load in California, and the load in California now takes on this GHG reporting and allowance requirements.
Correct.
But as you said,
yes,
they also get some money because back from the ISO to help buy those. So we've kind of already, as load, we've already paid for the GHG through the energy price because it was kind of baked in. So now we're getting some of that money to go buy allowances. So it's not like we're double paying for GHG. It's just we're kind of kind of paying for it differently than we do today.
Yes.
Okay. And then
today you're not getting that allowance.
Right. Today we don't have the allowance obligation and we don't get that extra money. Today, external generators get the money and they have an allowance obligation. So it's sort of a paradigm shift from today.
Correct.
Again, I'm not poo-pooing. I actually like these mechanics. I'm just making sure I understand it. And one other question, though. Is there any reason for sort of setting a baseline GHG intensity from outside before sort of optimizing, or can this be done so that CARB is confident that they don't have to do any sort of secondary dispatch calculations? It would be very attractive if these resolve the need for CARB to do anything for secondary dispatch. It would be a very attractive feature.
Yeah, it would be. I agree with you. If we could solve the secondary dispatch, identify it, price it properly, and including the optimization, you may consider that we have a solution that does it all. However, it's not easy to, it's very elusive to find out how much the secondary dispatch and then even price it to have that solution. So that's why this approach here, the hybrid approach, externalizes that fact and basically says, we're going to find the optimal solution to the market, optimizing energy and greenhouse gas regulation costs, and we leave any considerations of secondary dispatch and residual emissions to the regulator to handle ex post outside of the market. So also we were thinking of trying to combine this, but I have a feeling, Jeff, we haven't tried it, but I have a feeling that if you couple the problems, now you give the optimization other avenues to optimize one versus the other, and I'm afraid we're going to have a similar problem that I described earlier when we have those binary variables and link the dynamic attribution to the greenhouse gas reference, where you have a situation that you're harming external load for the benefit of internal load. I have a feeling that we may end up in a situation like that if we could ever try to adequately identify what we call secondary dispatch and price it and put it in the optimization. So I think for all practical purposes, in this approach, we leave that part out.
Just one more question. I'll stop. If we assume a GHG intensity of the power that's flowing to California, if we assume the intensity times the marginal GHG rate within the sending area, does that address secondary dispatch? How can secondary dispatch be worse than the marginal rate that's coming to us? And if you don't know,
by saying intensity, you mean the average intensity, though? It's not marginal. It's an average, right?
Well, I don't know because
you have multiple.
Optimization is always working on the margin, so we know what the marginal, GHG intensity is, and that's what's going to set the GHG rate, right?
Correct, and the actual intensity is less than that because
right. The average intensity is less than that, but if we are looking at marginal intensity, I don't see how a redispatch there could be any argument that there was redispatch effects if we were working from a marginal intensity level. Anyways, I'll stop.
Yeah, these are interesting thoughts that probably require more thinking and analysis.
Okay, thank you.
You're welcome. Any more questions in the queue?
Yes, I do see one more caller in the queue. Please go ahead. The line is unmuted.
Yeah, just restating based on Jeff's comments, that there's no neutrality issue with the LA approach and no double count. I mean, we're settling on the marginal cost of GHG, and that's why we're keen to have the reference point in there to get an accurate marginal cost. And then, to your point, Jeff, if you look at the marginal rate, and this is sort of after the fact, times, you would more than cover things, I think, with the marginal intensity, and that's why we advocated for weighted average intensity. That fully covers secondary dispatch and any leakage concerns. I don't think you need the marginal intensity. That would overcompensate, in my belief.
So in your proposal, Stuart, in the LA proposal, the regulator could potentially calculate the difference between the average intensity and the marginal greenhouse gas transfer revenue to perhaps estimate the residual emissions. Following up with your thought there.
Yeah, no, I think we would propose just a modification, and this is nothing to do with the market, obviously. This is more in for the regulating agencies, but CARB has the outstanding emission calculation, and we're proposing moving away from that default emission factor, which is based on gas emissions from a 2010 WEC study, to weighted average emissions, because that accurately captures the full intensity of what ran in that dispatch interval. And you've fully captured the environmental impact with that approach. I think Jeff was suggesting, if you use the marginal intensity, there absolutely wouldn't be any arguments, and I agree with that comment. It just would feel like we're more than capturing the atmospheric impact. I think if you just take the weighted average in the outstanding emission calculation, I think that's the right approach. That's for emissions, not costs. You use marginal cost for settlement.
I do not see any other. I do not see any other callers in the queue as of now.
Okay. Well, I hope I didn't exhaust all of you with all these different tabs and solutions. We had released this, so it's in your hands if you want to play more and examine more scenarios. We have some tabs here that we didn't have time to discuss. I don't know, Anya, if we have time to perhaps do one more, which I find interesting. You tell me.
Go ahead, George. For those that can stay on, since we have 14 minutes, go ahead.
So we saw how this works with the greenhouse gas reference. There is, what I want to show you also is what happens if you have also transfer constraints. So this tab here is the resource-specific approach that we don't have unlimited transfers. We put a scheduling limit of 50 megawatt on each transfer, either way, okay? So having a constraint like that, and we also have a greenhouse gas reference to observe here. So these are additional constraints that we throw in the problem. So obviously you have a higher cost, as you can see, compared to the base scenario. You can only attribute 30 megawatts to area 2. There is not much room on the transfers to get all the attribution that you want to offset that 330 megawatt of load, okay? So here you can only attribute 30 megawatts because you can only get 50 megawatts and another 50 megawatts around 100 megawatts into the BAA B. So the attribution is limited to 30 megawatts, which means that G2 needs to run at 300 megawatts to meet the 330 megawatt load. So that has additional costs. And if we go down to see the prices, you can see because you have transfers that are binding now between the BAAs, you have a full spectrum of price differences across the BAAs. In BAA-C, the price is $30 set by must be G7, okay? And the price in area B is $60, and the price in area A, in BAA-A, is $70. And you have marginal greenhouse gas transfers of $12 for the transfer into area 1, $23 for transfer into area 2. So if you add those to the BAA shadow prices for the power balance cost, for the power balance constraint, you get a full range. You get a rainbow of prices now that vary from $83 to $30. So you could have an effect where you have price differences between BAAs because of transfer constraints and price differences between greenhouse gas areas because of the greenhouse gas transfer. And that's what you see here in this example. The settlement based on these prices is the resource-specific settlement, where now what is interesting is that the market operator has a surplus of $6,010. Part of that is transfer revenue, okay? 4,000 is transfer revenue, okay? Because of the price differentials between BAAs. And then the rest is greenhouse gas transfer revenue, $1,320 for the transfer into area 1 and $690 into area 2, which in the resource-specific settlement, they're paid out to the attributions. And then the 4,000 transfer revenue, as we have discussed in the EDAM workshops, we split it 50-50 between the EDAM entities for the BAAs, or it's paid to the transmission customer that releases the transmission to be used as a transfer. So we will show the same solution here with the Ldwp approach. As you can see in the resource-specific approach, there's optionality here in the bids. Now, you will have exactly the same solution with the Ldwp approach, but the settlement, instead of paying the generators, you will return the greenhouse gas transfer revenue, only that part of the revenue, to load. Now, what I showed here in the Ldwp tab, I followed my thinking of having a full greenhouse gas bid, so you have more bids here as in the hybrid approach, and observing greenhouse gas reference. So if you do that, you have a more optimal solution than the one before, right? So it's not the same. You go to 65,200 versus it was 6610. So here you have a higher attribution for area 2, 90 megawatts. That gives you a lower cost. And if we see the marginal prices, again, you have a rainbow of prices because you have still constraints. The settlement is the zonal settlement. You still collect 4,000 for transfer revenue, and the remaining 4,000, 2,200 for area 1 is the greenhouse gas revenue that is paid to the load in area 1, and 1,800 is the greenhouse gas transfer to area 2 that is paid to the load in area 2. So you have all this at your disposal in what we published. Just keep in mind, this was my interpretation of the proposals, and at times is wrong. My interpretation of the zonal proposal was using a single hurdle rate, maybe the unspecified rate, without resource specific. That was my interpretation. And my interpretation of the Ldwp proposal was using full greenhouse gas bids, which is also not correct. The bids are inserted by the market operator, but there is an optionality in participating, which is expressed by the external resources. If you want to compare with what would have been the solution for this problem with transfer constraints and the full hybrid approach, then you go here to the hybrid 2. In this solution here, we have the same transfer limits of 50 megawatts, full greenhouse gas bid inserted by the market operator for all resources, and no greenhouse gas revenue, no greenhouse gas reference constraints. And you will see that this approach is the most economic in this case. You have a cost of 61,140 compared to what you see here, and there is no specific for 66 or the Ldwp approach for 65. This is the benefit and the motivation for the hybrid approach. You really get the lowest cost solution. Can't find it back now. It was here.
Great.
All right, that's it. I have nothing more to show.
Well, I'm not seeing any other questions in the chat or any other hands raised. So just wanted to thank stakeholders today for great engagement and a lively discussion. And also a big thank you to George for putting together this tool to compare the models and for reviewing it with us. As follow-up to today's discussion, we will repost a spreadsheet with some of the updates discussed and identify what changed from the version that was posted yesterday. We also look forward to receiving examples from participants as was discussed on the call. So just wanted to say thank you again and have a good rest of the day.
Thanks, Anya. And before we log off really quick, I just wanted to give one final reminder of the ISO Stakeholder Symposium that we'll be holding November 9th and 10th in Sacramento, California at the Safe Credit Union Convention Center. So registration is now open for that event. So be sure to register before August 15th to take advantage of the early bird rate. But then, of course, you'll be able to still register after that point as well. But if you have any questions regarding the symposium, you can send an email to symposiumreg@kaiso.com. Thanks again, everyone, for joining us today, and have a great rest of your evening.
That concludes our conference. Thank you for using Event Services. You may now disconnect.